Okay, so I'll start here by working on the first problem that was listed there, which is sine of 2x is equal to negative 1/2. So I've kind of broken this into 5 steps. So I'll go through those 5 steps with this first problem, so you can kind of get the hang of it. And then I'll also post videos of the rest of the problems on that sheet that you can kind of reference to check in, make sure that you're doing it correctly. So step 1 for this problem is going to ask, what is the argument and what is the interval? So I forgot to put the interval up here. That's what we're working with. That's our interval. So what is our argument and what is our interval? First things to ask to kind of get your bearings in the question. And for this question, our argument is going to be whatever is used to represent the angle measure. So this would be like, usually you'd see like sine theta equals, that theta would be your angle measure. So we're just asking what's representing our angle measure in this problem. So instead of theta here, we have 2x. So our argument is 2x, and our interval, so your interval is going to be where your solutions should fall between. So you're given a minimum value and a maximum value, and the whatever solutions you find to make this statement true, whatever values for x you find to make this statement true, those should fall between this minimum and this maximum value. So our interval for this, as written up there, is 0 is less than or equal to x, which is less than or equal to 3 pi. So that's what we're working with for this problem. And I'm just gonna box whatever we kind of like come to in each step, whatever's the end product of each step here. So we can move on. Step 2 for this problem is going to be finding all the unit circle values that make the statement true. So for this problem, we're looking for all the unit circle values, all of the angle measures. So these values are angles, usually in radians, but it depends on what your interval is. But I don't think I've ever seen an interval given in degrees. So for the time being, we'll just say it's going to be whatever your angle values are in radians that make this statement true. So you're looking for an angle that you could sub in for the 2x value that would make this statement true. So you're looking for whatever you can sub in for this to make this statement true. So we're going to say that our argument has to be equal to a certain angle measure in order to make this true. So to find those angle measures, I'm going to bring up the unit circle here. You can kind of see that. Sorry, this is in pencil, a little tougher to see. So we're looking for an angle measure where sine is equal to negative 1/2. So looking here, when sine is negative, you know you're going to be working in the bottom half of the unit circle, because that's where our y values are negative. And y is sine. If you remember, your cosine is your x value on your unit circle, and your sine is your y value on your unit circle. So we're looking for negative y values, which will give us negative sine values. and we find that right here we have sine equal to -1/2. So that's at 7 pi over 6 radians. So I'll come over and write that over here. 7 pi over 6 is our first reference angle value from the unit circle. And we'll look over here and find that we have a -1/2 sine value right here again, and that is for 11 pi over 6. So there we go. Those are our two values on the unit circle that match. And so those are what we're going to be working with from here forth. We've kind of gotten our grounding for the next steps here. So step 3, moving forward, is going to be kind of taking a step back and now using this information to make sure that we have the correct interval identified. And we're given an interval that we're working with, but we have the freedom to kind of manipulate that in order to make those values something that are easy to work with, given these reference angles right here. So you notice right now, if you were to be looking at this, you'd say 11 pi over 6, and you'd be asking, is that within my interval? And I mean, it's not too difficult to see that it is, but it would be much easier if these had denominators that matched, so you could see where the fraction would fall. So that's what our goal is here. And while we're doing that, while we're getting the denominators to be the same as those in our reference angles, so it's easy to compare, we also have to take into account what our argument is and kind of adjust our interval so that the x value matches. So we'll do that here in step 3. So we're going to adjust our values in the interval to match our argument, and then we're going to get a common denominator for our reference angles and interval measures. Okay, so I'm gonna transfer our interval that we're working with now down here, so that's still 0 is less than or equal to x, which is less than or equal to 3 pi. And we'll start by adjusting to accommodate for the change in x that needs to happen to match our argument. So in order to do that, we're going to multiply all these values by 2, because that's what we would do here if we were going to try to get x to be 2x, we'd multiply it by 2. But remember, for an equation, what you do to one side of the equation, so if this was like x equals 2, and we wanted to multiply this side to be 2x, you'd also have to multiply this side by 2 to get that to stay, that equivalency to carry on. So this is an equation. It has 2 equal signs, but it's still an equation. So you have to multiply all of these values by 2 to make sure that all 3 sides of the equation, I guess, are staying in the same kind of ratio and equivalency as you would need to multiply this by both sides by 2. You need to multiply all 3 sides by 2 over here. So to do that, just make a note. Multiply all values by 2. So 0 times 2 is still going to be 0. X times 2 is 2x. And 3 pi times 2 is going to become 6 pi. Okay, so great. Now we have, we've adjusted so that our interval, our x values match. So now we have to get a common denominator. So if we look up here for the reference angles that we identified up here from our unit circle, we see that the denominator is 6. So to get that down here, we're going to multiply all of these values by a fraction that has 6 in the denominator, but that's equal to 1. So it's like multiplying all these values by 1 in a way that's going to give us 6 in the denominator. So we're going to multiply all of these by 6 over 6. And that value, it's not always going to be 6 over 6. Say if these values had 3 in the denominator, you'd multiply by 3 over 3 in order to get that to be equal. But in this case, we're working with 6 in the denominator, so we're going to multiply 6 over 6 because this really equals 1, so we're really just multiplying all of these numbers by 1, but it's kind of in a little sneaky, tricky way that's going to give us 6 in our denominator moving forward. So 0 times 6 over 6 is still 0. 2 times 6 over 6 is going to be 12x over 6. And then 6 pi times 6 over 6 is going to be 36 pi over 6. Okay, so now with just those 2 easy steps, we have this now kind of revised interval that's now going to be much easier to make comparisons with our reference angles moving forward as we try to identify all of the angles, not just these 2 angles that make this statement true. Okay, so I'm going to move on. Oop, lost our paper there. To a new paper. So I'll transfer what we have now, which is that sine 2x is equal to negative 1/2. We know that 2x is equal to 7 pi over 6, and that 2x is equal to 11 pi over 6, because those are our reference angles that we identified. This is the original problem. And we now have our revised interval that is 0 is less than or equal to 12x over 6, which is less than or equal to 36 pi over 6. And it's okay, you'll notice that these aren't simplified. Obviously that's okay, because if you were to simplify them, then that would just get rid of what you did with the 6 over 6 values, and we want to keep that 6 in the denominator. So even though this could be 2x, obviously that's what we started with, you want to leave it in the unsimplified version. So now that we have that, we're ready to move on to step 4. And step 4 is going to be to find all of the other angle measures that make this statement true, using these as our starting point. So we're going to do that, we're going to add and subtract 2 pi from or to our reference angles to find all possible values within our interval. Okay, so I'm just going to copy these back down here. So you have 2x is equal to 7 pi over 6. 2x is equal to 11 pi over 6. I'm just going to box these so they kind of stand out. Okay, so I'll kind of explain what we're working with 2 pi here. So you know with your unit circle that these 4 main points here, you have 0 pi, you have pi over 2, you have pi, and you have 3 pi over 2, and then you get back here to 2 pi. So one full rotation around this unit circle is equal to 2 pi, because you're going from 0, 0, pi over 2, pi, so that's 1/2 is pi, so then the full thing is 2 pi. So we have these reference angles that we've identified here, and so those would be theoretically sufficient answers if our original interval back when it was in the question as 0 to x and then x to 3 pi, if our original interval had been from 0 to 2 pi, then the answers that we've identified now would be sufficient, because those are the only answers that exist and make that statement true on the unit circle, which is from 0 to 2 pi. But when we're working with intervals that go beyond the angle measures of the unit circle, as is the case here, because we go all the way up to 3 pi, which is not on the unit circle. Oh, that's here. 3 pi, which is not on the unit circle. You have to keep adding one full rotation to get to the values that aren't shown here. So for example, I think this will make more sense as I kind of keep going and doing it out. But okay, so we're working with, just ignore this right now, that's not there. So we're working with 7 pi over 6. So we're going to add 2 pi, we're going to add one rotation to 7 pi over 6, because we know that at this line, that sine is equal to -1/2. And that's what we're trying to prove, that's what the angles that we're trying to prove true right now, is that we're trying to find any angles where sine equals -1/2. So we're finding any possible angle measures that could go with this line. So right now we have 7 pi over 6, so we're going to do one full rotation to find what that angle value will be after one rotation. And to do that, we're going to add 2 pi, because that's the angle measure of one rotation in the unit circle. So here, going back, when you add 2 pi, when you're adding and subtracting fractions, you have to get your common denominator. So we'll go down here. You have 2 pi over 1 right now, and you're trying to get a common denominator of 6. So like we did with our interval, we're going to multiply by 6 over 6, which is like multiplying by 1, but it has 6 in the denominator, and multiply across. So that gives you 12 pi over 6. So that's what we're going to add to each of these, because that's equal to 2 pi. And then, so we can see what each of our rotations will give us. So we're going to add 12 pi over 6. So remember, when you're adding your fractions, you don't add the denominators, you only add the numerators. Unlike when you're multiplying, you multiply both the numerator and the denominator. When you're adding fractions, you leave the denominator the way it is. You only add the numerators. So adding 7 pi plus 12 pi is going to give you 19 pi over 6, and we'll box that because that's another angle that's kind of equivalent to our 7 pi over 6 if we were to rotate around again. And we can look now, because our interval is now in the same terms, that we can see that 19 pi over 6 falls within this interval. So we're good. So we'll keep adding on here. Add another 12 pi over 6, another rotation to find another equivalent angle for that one line that we're looking for on our unit circle that we know gives us -1/2. So adding another 12 pi over 6, we get 31 pi over 6, and we'll box that because again we see that that is equal to our interval up here. So we'll add another 12 pi over 6, just keep going here. This will give us 43 pi over 6. So we'll box that one. But you should have red flags going off because 43 pi over 6 is greater than 36 pi over 6. So we know that that's outside of our interval. That can't be our solution. So we know that we've gone as far as we can adding. You'll notice up here it says add or subtract 2 pi from our reference value. If we were to subtract 2 pi from this, if you were to do 7 pi over 6 minus 12 pi over 6, that would give you a negative value. And if you look up here, our bottom limit is 0. So we can't have any negative numbers as the solutions for this problem. So now that we've kind of maxed out there all of our possible answers, we'll move down to this reference angle and do the same thing. So here, this gives us 23 pi over 6. So that's the angle measure after one rotation there, adding one other unit circle on top. And that's still good. That's less than 36 pi over 6. So we'll do it again. Add 2 pi. Get 35 pi over 6. Box that. And you'll see, oh, we're still good. It's 1 under, so we can keep adding theoretically. Just to kind of demonstrate. So once you add another 12 pi over 6, another 2 pi, you'll get to 47 pi over 6, and obviously when you look up here, 47 pi over 6 greater than 36 pi over 6, so that one is a no-go. If you look to subtract from this one, you'll notice that subtracting 12 pi over 6 from 11 pi over 6 would give you a negative value again. Our interval starts at 0, so we only want positive numbers, so we know that we've maxed out both of our reference angles for this problem. So now we're working with these 6 angles right here, and we can move on to step 5. So for step 5, it's kind of this is the last step. We're going to treat each angle measure like it's a mini equation with our argument. Oh, that's not how you spell equation, so sorry. Talking while I'm writing. Like a mini equation to solve for x to find our final angle measures. So yay. So we'll copy these down. So right now we have that 2x is equal to 7 pi over 6. We have it equal to 19 pi over 6, 31 pi over 6. Then down to the second row, 11 pi over 6, 23 pi over 6, and 35 pi over 6. Okay, so you can see that if we write these out as mini equations, I'm just going to put this over 1 so it's a little bit easier to kind of conceptually see. So you have 2x over 1 is equal to 7 pi over 6. To get the x alone, you divide by 2. I'm going to write it here as multiplying by 1/2, but that's the same thing. So your 2's will cancel. You're left with x. And then again, when you multiply fractions, you do multiply the denominator changes, so you're left with 7 pi over 12. So that's going to be one of our final angle measure solutions. So yay, we found one. So moving on to our next one, we have 2x is equal to 19 pi over 6. Write that over 1, multiply by 1/2. Those cancel. You'll get x is equal to 19 pi over 12. So you can kind of see the theme here. When you're multiplying, you're going to be multiplying all of these numbers by 1/2. So to kind of speed up the process, you don't have to do this, but for the sake of this video and getting it to upload to Google Drive, I'm going to kind of cut this off. But you do the same thing here. If you want to write it out, that's absolutely fine. Make sure that you don't make, any mental math errors. But I'm just going to stop at those two. But you would do the same thing for all of these numbers. Is to set all of these individually equal to 2x and then solve for x. So right now, those two that we found, 7 pi over 12, 19 pi over 12, 31 pi over 6 is going to become 31 pi over 12. 11 pi over 6 is going to become 11 pi over 12. 23 pi over 6 becomes 23 pi over 12, and 35 pi over 6 becomes 35 pi over 12. So that's our final answer set for this problem. So when you look at the original question of finding what values of x make this true, what values of x make sine of 2x equals -1/2 true, these are your values. And so yeah, there's a lot to kind of cover there, but with those 5 steps, you can really kind of tackle any problem. So I'll keep doing some more questions from that sheet. But yeah, you can watch them ahead of time, or you can try to do the problem on your own and then kind of check back to see how you did. But hope that makes sense.